Okay, so we mentioned that, again, what enzymes do for us is they lower that activation energy, make it easier for a reaction to occur, make it easier for the reactants to reach what we call a transition state. A transition state is where you've got these molecules where lots of energy is stored in them, but they're stable. You've got to get them to an unstable point to where then they will actually, they're unstable. They're more likely to break apart. In the case of combustion, they're more likely to burn. So that's the transition state is this high energy, contorted, molecules are all twisted. It's an unstable state a molecule reaches as a result of activation energy being added. And enzymes help get the molecule into that transition state. Right? And so I've just found a cool GIF here online, through their shape or exposing parts of a molecule to a polar region or a non-polar region forces the molecule to change its shape to a more unstable place. Sometimes an enzyme might be able to alter the pH within a certain region that the molecule attaches to, and that causes it to be a little less stable and more likely to release the energy and break apart or form together. And so some enzymes are designed to form things together. Here I've got one that is breaking sucrose down into its disaccharide into the two monosaccharides, glucose and fructose. So some terms here, make sure you look these up. I'm going to go through them kind of quickly, but write these down. You should be taking notes. Write these down and make sure you get good definitions out of your textbook for these. Substrate is whatever the enzyme, whatever's attaching to the enzyme that you want the enzyme to act upon. The active site is the location within the enzyme that has a specific shape that is designed to fit onto the substrate. It doesn't have to be, we used to think it had to be like a perfect lock and key, but we've actually learned more recently it appears that it just has to be kind of a general shape that can kind of form and induce a fit, form around the substrate. And then your products then are what comes out of the reaction after the enzyme has done its thing. Okay, so some terms there. Now, what prevents these enzymes from just constantly always just doing their thing, just producing way too many products? The goal of the enzyme is to make the reaction easier. What controls the reaction? Well, we don't want too many products coming off those enzymes. We've got various ways we can control those. One is what we call competitive inhibition. That's where a molecule binds in exactly where the substrate normally would bind onto the active site and prevents substrates from reaching the enzyme or being acted upon by the enzyme. You have what we call non-competitive inhibition. That's where something else basically locks in on the enzyme at another point, and it maybe changes the shape or changes the active site just enough that the substrate cannot bind to the active site any longer. And you can also have what we call feedback inhibition. That's where through maybe it's the first enzyme itself, or maybe it's a chain of different enzymes, but something produces a particular product then that becomes either a competitive or non-competitive inhibitor of the first of a previous enzyme. And so if this end product here, right, becomes an inhibitor for an enzyme further up the chain that produces it, then you slow if there's too many of these end products available in the cell, some of them will bind to this first enzyme, and that will slow then the progress of generating this end product. And we see that a lot. We call this a feedback loop. This also exists in electronics. We call a feedback loop, but that's another story. Anyway, I think that's our lecture for tonight. All right, guys, I'm going to get these videos uploaded to YouTube. Stay safe, stay warm out there. And again, we'll take test 1 as soon as I see you guys again on campus. All right, guys.